Alright, so we've been talking about using variables and evaluating expressions, knowing what their value is, but sometimes we just don't know what their value is, and if we don't know, there are other things we can do with them. In this case, we're going to be talking about addition and subtraction. Alright, so first, before we do that, I think it's important for us to understand what multiplication means. Because you'll notice all these expressions are kind of set up in the same way. It's a number times something. In these cases, we don't know what they are, but in this case, we do. So what does 4 times 5 really mean? Well, what it really means is 5 plus 5 plus 5 plus 5. That makes sense. That's why 4 times 5 is 20. Alright, so what does 2 times x mean? Well, that really means x plus x, which unfortunately we can't really tell what that's equal to, but 2x is equal to x plus x, or x plus x is equal to 2x. So what's the point of this? We're just going to try and get an understanding of what different things mean. 3x is the same thing as x plus x plus x. 3xy really means xy plus xy plus xy. I have some bad handwriting. Let me fix this. I want to make sure your notes look good. So that's x plus x plus x. Alright, 3y to the third really means y to the third plus y to the third plus y to the third. Alright, and 2x squared y to the third, as you probably figured out by now, is equal to x squared y to the third plus x squared y to the third. Now I specifically made these numbers small, so I wouldn't have to write them out like 8 times. So what's a negative number mean? Well, that means we have negative x minus x minus x, or it's negative x plus negative x plus negative x. If I keep change. Okay, let me actually look at it this way. That's negative x plus negative x plus negative x. Okay, and this is negative x to the third y squared plus negative x to the third y squared. Alright, so these are the two less common ones that people don't know about or they're unsure of, so let's make it a little more clear for you, the ones that students have trouble with. And that is, what is 1x? Well, 1x just means x. So that brings us to this rule here, which is very important. If an expression has no coefficient, it shouldn't really be an expression, that should be a term. If a term has no coefficient, its coefficient is 1. So if there's no number here, it's 1. All of these really have 1s. 1x plus 1x is 2x. 1x plus 1x plus 1x is 3x. 1xy plus 1xy plus 1xy is 3xy, and so on. All of these really have 1s here. We don't need to write them. It should be implied that they're 1s and that they're not zeros. So this is really negative 1x, negative 1x, negative 1x, negative 1x cubed y to the second, negative 1x cubed y to the second. Alright, and 1x is equal to x because it's 1x. So what is 0x equal to? Well, 0 times anything is 0. That's known as the multiplicative property of 0. Any number times 0 is 0. So 0x is the same thing as 0, which is the same thing as 0y, which is the same thing as 0x squared, which is equal to 0 anything. I'll call it 0 anything. Doesn't matter what it is. So these two rules are kind of important. So I want to have them in your notes appropriately. So let me erase this so it's not anything confusing. Let's get white back here. Alright, so these two things are important. 0 times any number is 0, and x without a coefficient, meaning the multiple in front of it, is equal to 1x. Alright, so let's take a look at how to add and subtract monomials. Alright, well, we saw that this really means 1x and 1x, so that's really x plus x and then these three x's, so this is x plus x, and these three x's are x plus x plus x. Both of these things will be added together. If you could tell, that's very obviously 5x. Alright, so what would negative 4x plus 2x be? Well, if you noticed yet, we just add the coefficients, so the 2 and the 3. So what's negative 4 plus 2? Well, negative 4 plus 2 is negative 2, so that's negative 2x. How about this? 2xy plus 3x. That's actually going to require a separate discussion, which we will have shortly. Let me make those red so they don't blend in with the problems. Alright, so these cannot be added. You'll notice this is really xy and xy plus xy, and this is x plus x plus x. But since we don't know what the value of those things are, we can't add these. These are called unlike terms. And they cannot be added. Okay, as are these. These are also unlike terms. This one might look like they are like terms, but they are not like terms. Those are all unlike terms. Okay? Because we can't write them out in this expanded form and put them together like that. Alright, so this is 3x squared minus 8x squares is the same thing as saying negative 5x squared. Okay, negative 5 plus 5, this is 0y to the third, and based on what we talked about before, that's really just the same thing as saying 0. But what about these? These don't appear to be like terms, right? But as we said before, 0 kind of has any set of variables because it's 0. So 0 plus anything is itself, so that's still 5x squared y squared. And these are unlike terms, so they can't be combined. Alright, so unlike terms can't be combined. Alright. Some people might think that this is 5x to the third, which it isn't. This is not correct. Don't put this in your notes like it's correct. It's not correct. Let's see why. Let's imagine that x was equal to 2. That would make this expression 4, and that would make this expression 12, which is 16. But that's if x was 2. Okay, if we plug in x is 2 here, we get 12. But if we plug in x is 2 here, if x is 2, we get 2 to the third, which is 8. 8 times 5 is 40. Which means these two things are not the same. Okay? Whereas in with like terms, it is the same. For instance, let's say x was 2 here. Then this is 4, and this is 6. 4 plus 6 is 10. Whereas 5 times 2 is 10, so they're the same. So you can only combine like terms. Like terms, if you might have noticed, have the same variables and the same powers. So they both have x's, and they're both squared. These terms are like terms only because 0 is a universal like term. These are not like terms because the exponents are different, and these are not like terms because they have a y. Alright, so let's sit down some definitions. Alright, so a single term, or a monomial as it's called, is the product of one or more constant variables and exponents. So the product of one or more, it's really supposed to say one or more variables and exponents and a constant. I wrote that poorly, I apologize. So in this case, the constant is the coefficient, which if there's none listed, like we said before, is really 1. Okay, so this is 1w to the 5th x to the 3rd y. Now a polynomial is a string of monomials connected using plus or minus. A single term is also a polynomial, so this is also a polynomial. So this has 1, 2, 3, 4, 5 terms. So this is a 5-term polynomial. A binomial means a 2-term polynomial. Bi is a prefix for 2, and a trinomial is a prefix for 3. So it has 3 terms. So trinomial, 3. Binomial, 2. Okay, and you'll see a lot of questions that ask about binomials and polynomials and trinomials and so on.